Howdy, it's Mr. Russell. Let's learn about solutions. Classify the following as an element, compound, or mixture. Now it's either going to be a homogeneous mixture or a heterogeneous mixture. Go ahead and pause the video. Whatever. You didn't pause the video. I know. Just explain it to me, Russell. Alright, so water is going to be a pure substance. It's a compound. And then calcium is an element. Alright, sugar water is a homogeneous solution, and a chocolate chip cookie is a heterogeneous solution. Since water is a combination of elements, it's a compound. If it is only one single element, it's an element. Now, a sugar water is going to be an element or compound mixed together in a even fashion to where you can't see it. Okay, and a heterogeneous solution or a mixture is a chocolate, like a chocolate chip cookie, is something where you can see the difference between the chocolate chips and the actual cookie. So mixtures are when two or more things are physically mixed together. So like trail mix right here, or the Kool-Aid man. Kool-Aid's got sugar and he's got water all mixed in there, but he's all red, right? So you can't visibly distinguish them. Or your gold ring even is a mixture. So a homogeneous mixture is a mixture that is completely uniform in composition. So its components cannot be actually seen. So good examples are a Kool-Aid and a ring. Now this ring here is a mixture of, let's say, brass or gold or different components or different types of metal. They're all evenly mixed and you can't actually see them. You just see the overall gold color. Now a heterogeneous mixture is a mixture that is not uniform, kind of like trail mix or salad. Okay, that's when we can actually see the differences. So let's try to describe what a solution actually is. So a solution is a homogeneous mixture of two or more substances in a single phase. Okay, so very frequently you will take a solid phase and a liquid phase and you will mix them together, and then they will exist in one single phase. So if you've made salt water before, that is exactly what you are doing. Okay, they exist in one single state of matter. That's what we mean by phase. The same composition and the same properties that are throughout. That's because it's homogeneous. Now, two extremely important terms for you to know are the solvent. That would be something like water. Water is a very common solvent, and that is what does the dissolving. And then a solute. That is what gets dissolved. So in our salt water example, solvent would be our water and solute would be the salt. So let's see if we can practice this and see if you can see the difference. Solutions can be in all three phases. So let's take a look. If we have sweet tea and it has two components, iced tea and sugar, which one's the solute, which one's the solvent? So iced tea has sugar as the solute, and it has the iced tea is the solvent. That's because the sugar dissolves in the iced tea. Okay. Now the gold ring. Now think for a second. Copper and gold. Now that gold ring is like expensive, but it's not exactly the price of gold. If you made an entire ring out of gold, it would be really, really expensive. So the ring is actually mostly copper with a little bit of gold added to it, or gold plating. So that's why gold is the solute and then copper is the solvent, because it's cheaper to make that way. It looks gold, but it's mostly copper. Now a cup of coffee. Well, caffeine dissolves in water, so caffeine's a solute, water's a solvent. Now the water in a fish tank, now we have oxygen and water. So the fish need the oxygen to breathe, or even the plant life in there needs is expelling the oxygen. So and that the oxygen is dissolved in the water. So the oxygen is the solute and the water is the solvent. Now the sealed can of soda, carbon dioxide is going to be the solute, and sugar water is the solvent. Now if you notice that water is almost always going to be the solvent, okay? So even iced tea is really, most of that was water in the first place. By the way, in alloy right here, when you have a solid and when you have two metals mixed together, or you have a solid and a solid, that is going to be called an alloy. All right. So this is going to be useful for your assignment here. If you have a solute gas dissolved in a solvent gas, that would be something like air. Gas dissolved in a liquid would be like carbonated drinks, liquid or a liquid dissolved in a gas could be like the humidity that you see in the air, right? We have liquid water that is ending up in our gas atmosphere. So liquids can be in liquids can be in solids, which is kind of crazy. You can actually pour like mercury liquid onto gold, and that's why I can't wear a gold ring if I'm working with mercury, because if mercury touches my gold ring, it will dissolve immediately into that gold ring, and it's really crazy to see. So a solid can dissolve into a liquid as well. You see that a lot when you dissolve stuff, and then a solid will dissolve in a solid. Okay. Now there are suspensions as well. So we're going to broaden a little bit, and we're going to get out of homogeneous mixtures. We're going to say that the particles in the solvent are so large that they settle out unless the mixture is agitated. So this is going to be a heterogeneous mixture. A good example is muddy water, and that's when the particles are over 1,000 nanometers. Okay, so 1,000 nanometers is actually 1 micron, or 1 micrometer. All right, so your filter paper is rated to the size of that, and it can filter out about that much. So the particles can be separated by filtration. Now, in the middle, we have solutions, and then we have suspensions. Now, in the middle are what we call colloids. Now, they're the intermediate size. Now, the particles are small enough to be suspended throughout the solvent, but there's still constant movement of the molecules. So they make up the dispersed phase, and the water is called the dispersing medium. All right. So a super good example of this is soap. So if you're at home right now, I suggest you try this. If you have a laser pointer, if you can shine it at some actual just water, or actually you just take the light on your phone, it should work. Shine it at normal water, and you get nothing. You don't actually see the light going through the water. But if you put it up against, put a little bit of soap in that water, mix it around, and you get soapy water, then all of a sudden you'll see the actual line or the beam of light that travels through that. And what you have made is a colloid. So this would be soapy water, and this would be just normal water. Now, the reason this little beam of light is called the Tyndall effect. Okay, it's a scattering of light. Super cool. So, just to check for understanding, which particle type has the smallest one? That would be the solutions. And then which one has the largest one? That would be the suspensions, right? Because we can filter those out, and it blocks light. Now the one that's in the middle is called the colloid, okay? Now that has a Tyndall beam effect. So there are several types of colloids here. There's the sol, which is a solid dispersed in a liquid. It could be like paint or mud. The gel is a gelatin. Liquid emulsion could be like milk or mayonnaise, Kind of weird, right? A foam, kind of like shaving cream or whipped cream. Now a solid aerosol could be like smoke or exhaust. A solid dispersed in a gas. Liquid aerosol could be like fog or clouds or an aerosol spray. And then a solid emulsion could be a liquid dispersed in a solid. They're kind of like cheese or a butter kind of thing. So these are all good examples, and they are on your assignment today. All right, now that's going to be it. So have a great day.